In this video I'm going to do a couple of different style questions on the use of small angles in radians for different trig expressions. And what we've got to do in these particular two questions is to prove two identities. Now there is a statement at the top which you need to be careful with. It says if theta is small enough to ignore theta squared, prove this identity and prove this identity. So what does that mean? Well, it means that theta itself you can't ignore, but you can ignore theta squared. Let me show you what I mean. If we're going to prove an identity, what you've got to do is say that that is equal to that somehow, or very close to it. So the objective here is to show that the left hand side, LHS, needs to be rearranged to make it look like that. So what I'm going to do is take the left hand side and rearrange it. And what I'm going to do here is realize that this is a compound angle, cos of that plus that. Now you should know your compound angle identity, which says that the cos of A plus B is the same as cos of A cos of B minus the sine of A sine of B. I'll just squeeze it in there. So you should be aware of that identity. So if we apply that identity to this expression, then obviously remember to double everything because of the 2 at the front. So we've got two lots of cos, so it's cos of the first thing, cos of pi by 3, cos of the second thing, cos of theta, minus sine. Don't forget I'm timesing it by 2 at the front, so you're going to get minus 2 lots of sine pi by 3 sine theta, like so. So approximately that is the same as that. So that's the same as that, and which is equal to, now the cos of pi by 3 is the cos of 60 degrees, if you like, which is a half. So the 2 and the cos pi by 3 can cancel, leaving you with cos theta there, minus, now the sine of pi by 3 is the same as the sine of 60 degrees, which is root 3 over 2 on a calculator. The 2 and the 2 will cancel, leaving you with root 3 sine theta, like so. Now as theta starts getting to be small, what you're able to do is now use the small approximation values that you should know. Cos theta is approximately 1 minus theta squared over 2. Take away root 3, and sine theta is approximately the same size as theta, like so. So this is approximately going to be equal to, approximately going to be equal to. Now you're told in the question theta is small enough to ignore theta squared, so we can ignore theta squared completely. That becomes 0, and you're left with an expression 1 minus root 3 over theta as an approximate evaluation for this expression, which of course is what we've got on the right hand side. So that's approximately equal to the right hand side, and there you go, QED, we've done the proof of the identity. So we work this through, and the theta squared can be ignored completely as 0, leaving you with just 1 minus root 3 theta. So let's just move this up, and let's do the second in a very similar fashion. Take the left hand side, and this time I'm going to use the compound angle sine of A minus B. So you should know that the sine of A minus B is the same as the sine of A cos of B minus the cos of A the sine of B. You need to know that compound angle identity. We apply that in this situation. So you're going to have 4 lots of sine A cos B, sine of A is pi by 4, cos of theta, minus, and then cos A sine B. But don't forget you're timesing it by 4. So 4 lots of cos A sine B, cos pi by 4, sine of theta. So that is the same as that using the compound angle identity, which is equal to the sine of pi by 4 on a calculator, or you should know it, sine of 45 degrees that is root 2 over 2. So you get 4 root 2 over 2 times the cos of theta, minus the cos of pi by 4 is also root 2 over 2, 4 root 2 over 2 sine of theta, which is equal to the 4 and the 2 cancel, 2 root 2 cos theta minus 2 root 2 sine theta. Okay, now what we're going to do is, let's say, let the angles, let theta in radians get very small. So we're going to say this is approximately the same as 2 root 2. Now cos theta is approximately 1 minus theta squared over 2. As the angle gets very small in rads, take away 2 root 2 and sine theta goes very close to being theta. If you now expand this out, well, you don't even need to expand this out, because it says in the question right at the very beginning that theta squared is small enough to be totally ignored. So that theta squared there disappears to naught as theta is tending to become small, so theta squared just disappears completely. Obviously, if you've got something very small and you square it, it goes even smaller. So theta squared can be just ignored completely. Expand now. 2 root 2 times 1 is 2 root 2. Take away, and then you've got 2 root 2 theta there. And then finally, to get the right hand side, take out a common factor of 2 root 2, and you get 2 root 2 bracket 1 minus theta, which is the right hand side. So there you go. There's this identity proven for small angle theta, provided that theta squared can be totally ignored and replaced with 0. And that's the end of this video.